The biblical description matches what we're seeing in the fossil record. And if somebody were making up those ages, I don't think that's the kind of detail that a forger would think to include, that if they're living longer, they would necessarily reach sexual maturity later. That's a hallmark of authenticity. So what the Bible is telling us about the longevity, the ages at maturity, that's lining up with what we see in the fossils.
Imagine a world where humans lived for centuries, and animals grew gradually, matured over decades, and lived far longer than anything we see today. According to the Bible, this wasn't unusual or supernatural. It was simply the way life worked before the flood. What's remarkable is that clues to this long-lost world may still be preserved today, not just in scripture, but in fossils. Fossilized bones are revealing growth patterns that point to longer lifespans in birds, dinosaurs, and other creatures that once inhabited the earth. Welcome to the Creation Podcast, where we explore how science confirms scripture. I'm your host, Mary Claire, and today we're examining evidence for pre-flood longevity through two fascinating lines of research: fossil birds and a new study suggesting that Tyrannosaurus rex took far longer to reach adulthood than previously thought. Joining us today is ICR scientist Dr. Jake Hebert, who has written extensively on both of these topics. Thank you so much for being here, Dr. Hebert.
Well, thanks for having me.
Of course. Before we kick things off, could you briefly share your background in science and some of the work that you have done here at ICR and how it connects to today's topics?
Sure. I'm a physicist, and most of my work at ICR up till now has been on the post-flood ice age and explaining how the ice age fits into biblical history. I've always been interested in giantism in the fossil record, even before I came to ICR. And so I'd already looked into that a little bit. I was intrigued by it. Years ago, I got a monograph called Scaling in Biology, dealing with why are animals the sizes that they are, why are different body parts the sizes that they are. And as you probably know, we've got a big push on biology here at ICR. And our president, Dr. Randy Galuza, asked me to look into scaling because he knew I was interested in that. And so I did, and it sort of just kind of swerved into longevity. I started seeing patterns with scaling that were tying into longevity, and so it just kind of led to that, and that's how we got here. I've always wanted to work on this kind of thing, but I was for a long time intimidated to do so because it seemed very daunting. And explaining this longevity is still somewhat daunting, but what I'm really tickled pink about is that we're finding more and more evidence that to confirm that people and animals were in fact living very long lives before the flood.
That's really cool.
And
that is exactly what we are here to talk about today. So really, to start us off, the Bible clearly states that humans before and slightly after the flood lived for hundreds of years. Yet it doesn't describe this as miraculous or supernatural or anything like that. So from a biological standpoint, why would longer human lifespans also suggest longer lifespans in animals?
Okay. If you assume that the human longevity was not supernatural, and I don't think there's any good reason to make that assumption.
No.
There's no hint in the Bible that it was supernatural or miraculous. In fact, I think most Christians, when they read the text, they just assume that there's something about that pre-flood world that was very conducive to great longevity. Well, once you reach the conclusion that it was normal in the pre-flood world, you're pretty much almost forced to conclude that the animals also would have experienced extreme longevity, because just about any mechanism or mechanisms that you can come up with to explain this greater human longevity would also have applied to the animals. And really, if you think about it broadly, there's only really two big options. One is that it's genetic, or it's environmental, or it's a combination of the two. Now, if it's genetic, we know that when God created Adam and Eve, there were no mistakes in their DNA. And their descendants, they may have had a few mistakes in their DNA, but not many. Well, you can make the same argument about the animals. They started out with perfect genomes as well.
Okay.
So if genetics was part of it, you're almost forced to conclude it would have also been true for animals. If you say it was environmental, the animals were living pretty much in that same environment that the people are, They're breathing the same air. So if it was environmental, you kind of have to conclude it would have applied to them as well. And if it was a combination of the two, that would have also been true. So you're almost forced to conclude that the animals would also have been experiencing very great longevity in that pre-flood world.
Yeah, that really makes sense. And so if life before the flood really was different than it is today, we should expect to see traces of that in the fossil record as well. So, and interestingly, even secular studies suggest that some animals like clams and sharks and crocodiles appear to have lived longer in the past. So when scientists study lifespans in animals, why are growth rates? Why is that such an important clue?
Okay, well, we got to be careful how we define growth rate because in some ways it looks like these pre-flood creatures were growing faster than we are now. If you look at the growth rates of some of these big, super big oysters, it looks like they were growing in absolute terms faster than oysters today in terms of body mass per unit time or length per unit time. But if you're talking about how long it takes them to reach their full adult body size, they're taking longer to reach that time because they're so big that even though they're growing faster in absolute terms, it's taking them longer to reach that full adult body size. So the key number here is age at maturity or how long it takes you to reach maturity. And there are all these studies in living animals that have shown that animals that take longer to mature just tend to live longer. Mm-hmm. So if you see evidence in an animal that it is taking a long time to mature, that is indirect evidence that it was living longer.
Okay. That makes sense.
Yes.
So what is that relationship between how long an animal takes to mature and how long it tends to live?
I don't know if we can point to a specific relationship, but if you make plots of one versus the other, if the age at maturity goes up, age at longevity tends to go up as well. It's not necessarily a one-to-one relationship, and some people have speculated, I don't think this is necessarily the case, some have speculated that the age at maturity may always be the same percentage of the total adult lifespan. I think that's going a little too far. I don't think I'm prepared to say that. But just as a general rule, though, you expect animals that are taking longer to reach maturity to live longer.
Okay, so even though it's not like a one-to-one relationship, with that principle in mind, why does it matter when we see evidence of delayed maturation in fossil birds in particular?
Well, for the same reason, it's an indication, it's an indirect argument that they were living longer than modern day birds. If you can show that they were taking longer to mature than today's birds, that's an indirect argument for a greater lifespan. And even the mainstream evolutionary studies they've become convinced that fossil birds generally took a lot longer to mature than today's birds. Today, most birds can reach maturity within a year or less, and often it's a lot less than a year.
Yeah, I've heard it's usually like months to years, right?
Yeah, or months, maybe even weeks.
Oh, wow, okay.
Maybe months to years, but definitely, most of them it's less than a year. But you've got fossil birds that look like they were taking longer than this. They might take several years to reach adult body size. The Archaeopteryx is one example. That's a very famous fossil bird. But there's a study that was published where they estimated that it took 2.7 years to reach its full adult body size. And even that's a little bit uncertain because they had to make some assumptions, but it looks like these fossil birds are taking longer to mature than today's birds.
Okay, well, with that, what do scientists see in these bones that makes them think they're so much older?
Okay.
What is it that they're looking at?
Okay, they're often looking at what we call long bones, and this could be like the femur or the tibia in the leg bone. And it turns out when you do the dinosaur studies, they will often do that as well.
Okay.
So when you look at a long bone and you cut it in cross-section, if you will, you've got something called the medullary cavity. I hope I pronounced that correctly. Medullary cavity. It's kind of the spongy part of the bone. And then there's this harder bone around it, the cortex, that's more compact. Within the cortex, there are growth rings or bands, and you can count those very similar to the way that you can count growth rings in a tree.
Okay.
And so they're looking at those and they're estimating, how long it was taking them to reach maturity based on that.
Right. Well, I know that when it comes to like the growth rings in trees, those rings do not necessarily represent like one annual year. So is that the same thing with the fossil birds?
That is one of the tricky things about this. And the question is, should you count all visible bands as representing a year? And that actually gets into the T-Rex study here in a little bit.
Okay, we're going to get there in a minute.
Because that's always been one of the complications in these kinds of studies. Now, another complication has been that the medullary cavity tends to expand as the animal grows. And so some of those innermost growth bands effectively get erased. So another big complication in these kinds of studies is what year do you assign to the first band? Okay, you can't necessarily assume that it should be one.
Right.
You had some bands that have been erased, but you don't know how many. And that's always been a big complication. Now, in some cases, they can get around that. For crocodilians, for instance, they don't think those are they don't think the growth bands are erased. Same thing with oysters. But in mammals, birds, and in dinosaurs, that's always been a big problem. And that's always been a complication. And that's, again, why this second study we want to talk about is so important.
Okay. Well, so some of the fossil birds were much larger than birds today. Can you talk a little bit about that? Like, how much bigger are we talking
Well,
right
I mean, you have these giant raptor-like birds. These are well known. You can look them up on the internet. There's fossil birds that were very large. But I think the evidence for longevity here is probably stronger on the delayed maturation. We've got some examples of really large birds. Also, we got examples of very large flightless birds.
Okay.
Okay. But I'm focusing more here on the delayed maturation. That's probably a stronger argument, I think.
Okay. Well, so they're much larger than birds today, but some of them even had teeth, which I think is super interesting. So I'm going to read something.
Well, let me throw in one thing. For instance, on the Archaeopteryx, we don't really know for sure how big Archaeopteryx got because they've got about a dozen specimens. They're all juveniles, and so they're kind of having to guesstimate what they think the full adult body size. But see, that's another issue. Sometimes we don't even have the full adult specimen. So we might have specimens that are just juveniles, and we're trying to infer a lot just from that.
Okay.
Yeah.
So diving into that, talking about the teeth, researchers like Yang and Sander have proposed that tooth formation is tied to incubation time.
Yes.
So I want to read something directly from an article that these two researchers wrote. So their article is titled "The Origin of the Bird's Beak," and they state, "A recent study on dinosaur incubation period using embryonic teeth posited that tooth formation rate limits developmental speed, constraining toothed dinosaur incubation to slow reptilian rates." So how could shorter incubation periods in modern birds prevent teeth from forming?
Okay. Well, they estimate, if you look at reptiles, they think that for a reptile, it takes at least 40 to 60% of the total incubation time for the teeth to form.
Okay.
Now, we're not saying that the birds evolved from reptiles. They would say that, but we wouldn't. But let's suppose they had a comparable development schedule. If for some reason today's incubation time is shorter for birds than it used to be, there might not be time for the teeth to develop. And there might even be epigenetic switches that tell the developing embryo, don't even bother trying to make teeth. You're not going to have time to do it. You need to focus on other priorities.
Right.
Now, that too, by the way, I was pleasantly surprised that this idea seems to be gaining traction even among evolutionists. For a long time, they've tried to explain why it is that today's birds don't have teeth. And honestly, this is something that we creationists have struggled with a little bit as well.
Okay.
Because they would say that the reason birds don't have teeth today is because they lost those teeth through mutation and natural selection. But they would argue the first birds had teeth because they evolved from reptiles. Now, we as creationists have tried to blunt the force of that argument by pointing out that some birds today have teeth. But you could fairly criticize us for saying that because no bird today has true teeth. They've got something, there are things called pseudo teeth. But no bird today actually has true teeth. So you could argue that was not a very good answer. But on the other hand, what is their reason for why the teeth went away? They didn't have a good answer either. They said, well, maybe they needed to save weight so they could fly. Well, bats today can fly. They've got teeth. A lot of this was very just so story kind of stuff. But what's interesting is I actually I was looking into this recently, and if you go to the Britannica.com website, which is the website for the Encyclopedia Britannica, they've got an article entitled "Why Don't Birds Have Teeth?" and they actually allude to this idea that the teeth development may be limited by the incubation time.
Hey.
They don't actually refer back to that 2018 paper that you mentioned, but they're alluding to it. So I think that idea is actually starting to catch on in evolutionary circles, that it's got something to do with a shortened incubation time.
I see.
Right.
Just out of curiosity, a question popped into my head. Is the diet different in birds that have these pseudo teeth versus birds that don't? Does that have anything to do with it?
I'm not sure.
Okay.
I really don't know. Apparently not all fossil birds necessarily had teeth either. Okay, some of them may not have. But today, no bird has true teeth, but you've got fossil birds that do.
I gotcha.
Yeah.
Okay, so the same link between growth rate and lifespan doesn't stop with birds, obviously. So when we zoom out to look at much larger animals like dinosaurs, we'd expect that pattern to become even more pronounced. That's why claims that massive dinosaurs reached adulthood in just a few decades have raised very important biological questions. So a recent 2026 Peer study proposed that Tyrannosaurus rex may have taken up to 40 years to reach maturation and its full adult size. So what evidence led researchers to revise earlier growth timelines?
Okay. Well, a little backstory on this will help. Okay, you had earlier studies that were published in Nature, a very prestigious science journal, which one of them claimed that the Apatosaurus, there was a 2001 Nature paper that said the Apatosaurus, which can be like more than 50,000 pounds, could reach maturity in 15 years. Now that's pretty amazing, right? If it's true. We humans take, around 15 years to reach maturity, and we only weigh, 120 pounds or something like that, 150, whatever. That just seems a little bit off. And there was another paper in Nature not too long after that said the T-Rex reached maturity in 25 years. Now, first of all, just from a biology perspective, that seems a little weird because there's all these studies that have shown over the years that larger animals tend to live longer. We know that just from personal experience. But biologists who've done these studies have shown that biological timescales in general tend to depend on body mass. Now, it's not a one-to-one relationship. If you double the mass, the timescale doesn't double. It'll become 68% greater, but it's the same idea. So just based on that, a lifespan, age at maturity, those are biological timescales. So the idea that something the size of a sauropod dinosaur could reach maturity in 15 years just seems a little bit off.
Right.
But also as a creationist, it sounds off to me too, because remember, I'm expecting animals in that pre-flood world to have long lifespans. Also, as a general rule, you expect large animals to live longer. These are like the biggest land animals that ever lived. You would just kind of intuitively expect them to have very long lifespans. And based on those relationships, you would expect them to take a long time to reach maturity.
Yeah.
So from the very beginning, I was a little bit suspicious of these very young ages at maturity for dinosaurs. In fact, I think, if I'm not mistaken, I got a little pushback on this at the 2023 International Conference on Creationism when I presented this research originally. One of the objections was, well, we know dinosaurs matured very quickly. Well, it turns out in 2013, there was a paper that was published by a guy named Nathan Myhrvold. He's something of a savant, a polymath. He's been described as the world's most curious human, and he heads up this organization called Intellectual Ventures. Well, he published this 2013 paper that's open access, by the way, where he went back and re-looked at all these dinosaur growth studies, and he was highly critical of them. He said a lot of them, they did not employ proper methodology. Some of them weren't reproducible. He was really critical of them. But there were two that he did not criticize, two in particular. And one of them was by a woman named Holly Woodward. And this was her master's thesis when she was at Texas Tech. And she did a growth curve for the Alamosaurus, which is a big sauropod from Texas. And she got an estimated age at maturity of about between 45 and 60 years for the Alamosaurus. Now, there was another paper he did not criticize by Thomas Lehman and Holly Woodward, where they looked at the Apatosaurus and they got an age of maturity at about 70 to 100 years. Depending on which study you look at, they say either 70 or 100 years, somewhere around there. Now, I like those numbers a lot better. That sounds a lot more reasonable to me as a creationist. Well, remember also I said that one of the big problems in these studies is that you have to guess at what the first age number should be assigned to that first visible band, because some of them effectively get erased. Well, wouldn't you know it, but Holly Woodward, she's since gotten married. Her name's now Holly Woodward Ballard, but she's at Oklahoma State University. She got together with Nathan Myhrvold, and they got together with Jack Horner, the famous paleontologist, and they did a study on the T-Rex.
Okay.
And what they did was they said, look, we're throwing away a lot of good data, because a lot of times they wouldn't even bother to use the innermost visible ring because they didn't know what age to assign to it. Mm-hmm. So they said, we're going to model these, but we're going to treat the age we assign to the innermost ring as a parameter in our model. And we're going to see what we get. So what they had was they had about 12 T-Rex long bones. I think almost all of them were tibias. I think there were a couple of femurs. Although if you know that you can sort of convert from tibia to femur, there's a way to do that.
Right.
So what they did was they had basically partial growth curves. They had about 12 partial growth curves. None of them were complete, but they had the bone circumference as a function of age. But again, you don't know what that first age is. But what they realized is you can slide those growth curves horizontally relative to one another, and you can get an overall growth trajectory, and there's still some uncertainty. Okay, there might be some erasure occurring in that in the smallest bone, but this method enabled them to use a lot more data. So this is a lot more rigorous. It's a better way to do this. And what they did is so good, this will probably become standard practice from now on, because it's a lot less subjective than what people have been doing before. And so what they also did was, another complication again is, do you count each visible band as some of them, you might have what they call a doublet, two that are very narrowly spaced. There are some that only show up under certain lighting that they call cross-polarized light. Do you count them all? So what they said, we're going to try all the possibilities. We're going to have a model where you count every single band. We're going to have another model where you count these bands but not these. So they had 4 different models, and so they tried them all. And when they did that, they got the best overall results when they counted every single band. And that's how they got that estimated age at maturity of about 40 years. And so it's the most rigorous study that anybody's ever done. Like I said, I wouldn't be surprised if it becomes standard practice. And the cool thing about this is that you can apply this to other creatures. Remember, this has been a problem for other creatures as well. Mammals, you've got that problem with mammals. You've got other dinosaurs, the sauropod dinosaurs, that you could maybe go back and redo those studies. And for all we know, we might find that even those ages of 60 to 100 years for maturity, those might be too low.
Yeah.
So this really opens up a whole new field, and it really, I think, is probably going to greatly increase the amount of data that we've got when it comes to looking at these fossil creatures.
Mm-hmm. That's just crazy that there are people out there who are so intelligent that can come up with these brand new models, and we can learn so much from them, much from each other.
Yeah.
But so if the T-Rex really did take decades to mature, like they suggest, How long do you think the T-Rex actually lived?
Well, it's hard to say. It's really hard to say. I don't know if I can give you a number, but for something like a sauropod dinosaur taking 100 years to mature, I don't think a lifespan of many centuries or even 1,000 years is far-fetched.
Wow.
I really don't. In fact, some of these giant fossil sharks, like the megalodon, I could easily see them having a lifespan of about 1,000 years, because even today, you've got the Greenland shark. They think it might take 150 years to mature, and it's pretty big. It's like, I want to say it's around 7 meters long. That may not be long enough, but it's a big shark. But you've got fossil sharks that are even bigger. So if something the size of a Greenland shark could mature in 150 years and may live to be 400 or 500 years old today, I don't have too much trouble imagining that something the size of a megalodon could have, a 600, 700-year lifespan or even more.
Yeah, and that makes a lot of sense to me.
Right.
Like, all of these fossils are just pointing towards longer growth periods and potentially the longer lifespans.
Right, yeah. We're not finished on this longevity research. There are 4 more papers that are already in the pipeline. So you haven't seen everything that we've got yet.
And so the next question becomes how those same observations are interpreted. Because a lot of the scientists will come up with the same data itself, but they don't always agree as to what that data actually means. So when evolutionary scientists encounter evidence for delayed growth and long maturation in fossil animals, how do they typically explain that?
They would say it's just a coincidence. They would say, look, you haven't looked at these other animals. These other animals, maybe they had short lifespans, and that's a fair point. But I think as we get more and more data, we're going to start seeing that this is the norm. The norm is for these fossil creatures to take a very long time to mature.
Yeah.
And so I don't know if they really haven't. They would use the natural selection paradigm. They would say that these adaptations are caused by broken genes, mutations, natural selection. Of course, we at ICR think that is a terrible paradigm. The epigenetic idea that these things are responding to changing conditions, I think that makes a lot more sense. That there could be epigenetic switches that tell these developing embryos, hey, look, you're not going to have time to make teeth in the egg. Don't even bother. Just shut that down and devote it to something else. That's engineering on an entirely another level. And of course, God gets even more glory for that, because that's just amazing engineering. So we think that the right way to look at this is something God has programmed into these animals to respond to changing environmental conditions. This is not broken genes. This is something else. And as far as the connection to longevity, they just haven't gone there. To me, if you look at the literature, it's obvious that if fossil birds were taking longer to incubate, it looks like they would have been living longer, but they don't go there. They don't make that next logical connection. Right. But I think it's pretty obvious that that's where you would go. Yeah.
Definitely.
Yeah.
And you kind of actually talked about this a little bit at the beginning of the podcast, but from a biblical perspective, how do those ideas like a more pristine genome and a more ideal pre-flood environment help explain this widespread longevity in both humans and animals?
Well, to me, it makes more sense. But again, it's not a detailed explanation.
Yeah.
Okay, explaining this in detail is tough. But if you should find that this is the norm in living creatures, and we've already found evidence for this in oysters, small mammals, a bunch of fossil oysters, small mammals, the Deinosuchus and the Sarcosuchus imperator, which are these crocodilians.
Yep.
Maybe not crocodiles per se, but crocodilians.
And you mentioned the sharks earlier.
The sharks, we got multiple instances of sharks taking longer to mature, as well as evidence that some extant sharks were probably larger. And there's giantism all over the fossil record. Right. To me, that's a better explanation. If this is the norm, then it makes more sense to think that this was partly environmental, but possibly also genetic, due to the fact that there were very few mistakes in everybody's DNA before the flood.
That makes a lot of sense.
It does, yes.
So why should Bible-believing Christians pay attention to evidence for longer lifespans in animal fossils? Why does that matter?
Well, it goes to, is the Bible telling us the truth about Earth history? And I'm sorry to say that among a number of prominent Christian apologists, there is this trend to say that the ages of the patriarchs in Genesis are symbolic. There's no hint of that. Genesis is clearly meant to be taken literally. And what I'm saying is, look, based on Genesis, we ought to expect the animals to have greater longevity as well. And we're seeing that in the fossils. By the way, there's an important detail in Genesis 5 that should not be overlooked. The youngest age at which one of the Genesis patriarchs is listed as having a son is 65. That is the youngest age. Now, some of these ages are much longer than that. In fact, I think one of them is 182. So we don't know that these sons were firstborn in every case, but it's a good bet probably some of them were. And even if they weren't firstborn, it's obvious that age of 65 is much closer to the start of their reproductive lives than 182.
Yeah.
So what that strongly suggests is that humans were taking longer to sexually mature. Well, guess what? It looks like the animals were too. So all of that fits. The biblical description matches what we're seeing in the fossil record. And if somebody were making up those ages, I don't think that's the kind of detail that a forger would think to include, that if they're living longer, they would necessarily reach sexual maturity later. That's a hallmark of authenticity. So what the Bible is telling us about the longevity, the ages at maturity, that's lining up with what we see in the fossils.
Yeah, you know what? That just kind of makes me wonder, do you think that women were pregnant longer back before the flood?
I think so. I think, yes. And you got to take the good with the bad, I guess. Pre-flood women, they probably had a very long lifespan, but the gestation time for humans before the flood could very well have been more than 9 months.
That is incredible.
Yeah.
Goodness gracious. Okay.
Right.
Well, Dr. Hebert, thank you so much for sharing your insights with us today. As we wrap up, what are 3 key takeaways that you want our viewers to go back home and to really take away from this episode? Well,
the main thing is that the Bible should be taken seriously. It grieves me that so many evangelicals seem to be running away from a literal understanding of Genesis when the evidence for it is getting stronger and stronger all the time. People would have you believe that evidence for creation is getting weaker. That's simply not true. The exact opposite is actually occurring. Evolution is getting weaker. And when I say evidence for creation is getting stronger, I'm not just talking about evidence for design. I'm talking about evidence for the biblical timescale of 6,000 years. Evidence for a literal worldwide flood. That is getting stronger all the time. So to me, that is the number one takeaway from that. I guess there are some other smaller takeaways, but the big one is, to me, that's the takeaway, is that when we look at the science, when it's done right, we see that it confirms what the Bible says.
And that's the most important thing that anybody can take away from any of the episodes that we put out there on YouTube.
So people should be encouraged by this. Bible-believing Christians ought to be greatly encouraged by this. And if you want a third takeaway, I think those who are scoffers need to seriously reconsider their worldview. By the way, I know what some of the scoffers are going to say. They're going to say, you silly creationists, dinosaurs lived millions of years before people. How silly of you to use dinosaurs as evidence for greater longevity. Well, we obviously disagree with that. And there is strong historical and scientific evidence that dinosaurs lived recently. The fact that you have soft dinosaur tissue in these fossils shows they can't even be 1 million years old. Based on well understood chemistry, we know that things like collagen cannot last even 1 million years at reasonable temperatures. So we've got strong scientific evidence that these creatures lived recently. They didn't live millions of years ago. They lived at the time of the flood, that these fossils were killed and buried during the flood. And so it's perfectly legitimate for us to be using these fossil creatures as evidence for longevity in that pre-flood world. Remember, these fossils, not just dinosaur fossils, but all the fossils, with the possible exception of some Ice Age fossils, these are in water-deposited sediments from the flood. And even evolutionary scientists, even uniformitarian geologists will acknowledge nearly all sedimentary rocks are water deposited. Now, they will try to argue some of them are deposited by wind. We think they're misinterpreting the data. And they will also try to tell you that some of it was deposited in lakes under tranquil conditions. There's good reason now to question even that. But even the uniformitarian geologists will acknowledge nearly all of these are water deposited. So when you see these creatures entombed in mud that later turned into rock all over the world, that is exactly what you would expect from a Genesis flood.
There is, definitely is. If you learned something interesting in today's episode, be sure to like and subscribe and share it with someone who enjoys learning more about God's creation. You can also support our ministry by joining our members and patrons community, whose names are scrolling on the screen right now. So one of our viewers from Facebook actually had a question for you, Dr. Hebert. Well, you've obviously done a lot of studies on longevity. That was today's topic, but you also have extensively done research about the Ice Age.
Right.
So I think you are the perfect person to be able to answer this question. So Colton Morrison wants to know how Antarctica accumulated the snow and ice, which built the glaciers hundreds of years after the flood.
Okay, well, I'm not sure exactly what the question is. Obviously, the full extent of the ice would take longer than just a few hundred years. He might be alluding to the fact that creation researcher Mike Ord thinks that in some places the ice accumulation was delayed. Okay, but as a general rule, the Ice Age would have started right away. Now, there may have been like some places where it was delayed, but as a general rule, you're going to get that ice starting to form quickly. And you could have the ice, we think you could get thick ice sheets in hundreds of years, okay? Not 100 years necessarily, but hundreds of years. And basically, it's because the accumulation rates, we think, were much higher during the Ice Age than they are today. Now, today, the accumulation in Antarctica, for instance, is very low. It's a polar desert. You get a very little amount of annual ice accumulation. But we think that during the Ice Age, however, you had very warm oceans because of all this rapid seafloor spreading during the flood and all that volcanism. And so you're going to have oceans that are much warmer, tens of degrees warmer than they are today. And that's going to put all this moisture into the atmosphere, and that's going to give you a lot more snow and ice during the Ice Age. And so that's going to enable the thick ice sheets to form relatively quickly. And so we don't need tens of thousands of years, or even really thousands of years to get thick ice sheets. If the accumulation rate is high enough, you can get it in even just hundreds of years.
Wow, well, it's incredibly interesting.
Yeah.
Well, thank you so much for answering that question for us, Dr. Hebert, and thank you, viewers, for watching. And also, thank you, Colton, for sending in your question for us to answer here on this podcast. If you have a question for any of our scientists, we will link a form in the description, and then you can submit your very own questions. But we'll see you next time on the Creation Podcast.